Okay, good morning, Year 10. Last lesson we looked at cylinders. Today we're going to look at spheres, but before we do that, there's a starter on board for you. So if you look here, you are actually given volumes of cylinders, and what you've got to do is work backwards to find the radius of each of them, okay? Now you're going to need your calculator for these because the answers need to be rounded to 2 decimal places. Okay, remember that your volume of your cylinder is pi r squared multiplied by the height, or is it the length? I can't remember. Whatever it is, you multiply by the distance between the two circular faces at either end. Okay, what I'm going to do is I'm going to ask you to pause the video and do those questions, and I'm going to come back to the answers at the end because I don't want anyone cheating and doing things before them too. So once you've done that, write your date, title and learning objective. So today again we're working on spheres, potentially hemispheres at some point I think as well, and we're going to learn to find the volume and surface area of them. Now get your highlighters out because it's one of those moments. The volume of a sphere is given by 4/3 pi r cubed. Now I believe that you have to actually memorise these formulae for the surface area and volume of a sphere. So you need to memorise them, okay? Now that 4/3, by the way, has nothing to do with this, okay? This is just a random sphere on the side, so ignore that. That is for every single sphere. That applies to every single sphere, okay? So let's have a go at some examples. All right. So for those of you that are artsy, you can give drawing the sphere a go. I won't, I'm sticking to my copy and pasting, okay? So find the volume of the sphere above and leave in terms of pi. Now this would therefore be a non-calculated question because you're asked to leave it in terms of pi. So your volume is going to be 4/3 pi r cubed. Now let's see if we can get my cubes and my squares the right way around this today. Now your radius is 4 centimetres and that's given by this length here. So from the distance from the centre of the sphere to the surface of the sphere. We can just substitute that in. So 4/3 pi times by 4 cubed. Okay. Where has that disappeared to? Here we go. Okay, so after we've done that, we can work out 4 cubes. That means 4 times 4 times 4, so that's going to be 64. So V is equal to 4/3 pi multiplied by 64. Now, when we're finding 4/3 times by 64, what we've got to do here, you can kind of think, is 64 divisible by 3? No. So what we're going to have to do is we're going to have to multiply 4 by 64 and then write it as a fraction over 3. So 4 times 64 is 256 over 3 pi centimetres, wait for it, cubed. There we go. Okay, so that's your answer. Make sure you write that down, please, and that's your first example of finding the volume of a sphere. Let's have a look at some more. So here we've got, again, we've got a sphere and then we've got a hemisphere. Now, we're not going to do them as multiples of pi. We're going to do them as decimals because we've already done multiples of pi. So the sphere over here, your volume, again, 4/3 pi r cubed. Okay, and we can just do V equals 4/3 pi 3 cubed multiplied by 3 cubed. Now if you pop that into our calculator using the fraction button, 4/3 pi multiplied by 3 cubed, I get 36 pi and we want it as decimals. We'll do it to 1 decimal place, shall we? So V equals 113.1 centimetres cubed. Okay, and that's to 1 dp. All right, so that's the first one. Now let's have a think about this hemisphere. We know hemisphere is just a half of a sphere, so what we can do is we can incorporate a half into our formula. So the volume of this hemisphere is going to be a half times by 4/3 pi r cubed this time, isn't it? So substituting in the value of 6, a half times by 4/3 pi 6 cubed. We can just type that into our calculator. So using a half times by 4/3 pi 6 cubed, and we get 144 pi, which to 1 decimal place 452.4 centimetres cubed. Okay, so I would encourage you to kind of incorporate the half in the start so you don't forget at the end to divide it by 2. Yeah. Okay, now moving on. We're doing this all in one go because obviously you would have 2 hours of maths today. Anyone miss those 2 hours of maths? I do. So you've got the surface area of spheres now. Okay, so here's a bit of an explanation as to why the formula of the surface area is 4 pi r squared. Well, we know that pi r squared is just the area of a circle, so that 4 at the front means that the surface area of a sphere can be given by 4 circles. And there's a good kind of illustration here of a tennis ball being made up of 4 circles. Okay, and that's why the surface area of a sphere is just 4 circles with the radius given. So that's really good. So you can get your highlighter and pop the formula of the surface area is 4 pi r squared. Okay, and hopefully you won't forget that. Whenever you think of finding the surface area of a sphere, just think about what a tennis ball is made up of 4 circles or 4 circular patches. Okay. So again, I think you have to memorise that, but you can come up with your own ways of memorising things. Okay, so obviously the sphere is going to be quite simple, but the hemisphere you need to think a little bit more out of because the hemisphere has 2 faces. So let's have a think about the sphere. So the surface area is 4 pi r squared. Now your r for this is 3, so that means your surface area is 4 pi 3 squared. Now we can type that into our calculator because it says enter your answers as multiples of pi or as decimals, so we'll do both. So 4 times pi times by 3 squared. And that's 36 pi, so that would be your answer in terms of pi. And then if we do it to press SD, it would be 113.1. We had that same answer before, didn't we, actually? Centimetres squared. She's correct this time. Good. Okay, and then the hemisphere. Now, let's think about this hemisphere. So we know the radius is going to be 6 metres. That's fine. Oh, did I do metres for the other one? Did I say centimetre? Oh, I said centimetres. Look at me, that's bad. Metres. See, caught myself again. There we go. Okay, back to this one. So you have to think about what's that area of that circular face and what's the area of the curved edge. Now let's think about this. So the curved edge, I'm just going to say curved, would be 1/2 times by 4 pi r squared. So that would be, I'm going to do 1/2 times 4, 2 pi 6 squared. Okay, 1/2 times 4 is 2, so that's where that 2's come from. So 2 times pi times by 6 squared gives me 72 pi. I'm going to leave it like that. I'm not going to change it yet because I haven't finished. Then I'm going to think about the circle. And that's just going to be pi 6 squared, isn't it? So that's going to be 36 pi. So the total surface area is this and this added together. So add 36 pi and that's 108 pi altogether. So total 108 pi meters squared. That kind of looks like 168, doesn't it? Hang on, I don't want anyone thinking that that's 168, it's 108. Pi meters squared, and then if we do it to one decimal place, 339.3 meters squared. Lovely. Okay, so you can see with a hemisphere you need to split it into the circular face and the curved face, and actually if you think about it you end up with just doing, so you've got 2 pi 6 squared, add another pi 6 squared, you actually end up doing 3 pi 6 squared, which I'm not sure if anyone can tell me if that works for every single sphere. I want you to think about it. Okay, next thing I'm going to ask you to do, so I've got 3 questions for you to do, so it's exercise 5.5, 15.2s, question 6 and 7, so really quick questions there, just one to find the volume and then one to find the surface area, and then there's a really good question here about cylinders and spheres. Okay, and you've got to find the volume of the empty space in the tube that's been filled with 3 balls, okay? So please do those questions, send me a picture of your work. Now those of you that want a little bit of a extension question, an exam question, I have got one for you today. Now, the diagram shows a cylinder of radius 10 centimetres. It already contains water to a depth of 15. A metal sphere with a volume of 900 centimetres cubed is placed in the water. Calculate the height that the water level rises. So, real kind of thoughtful question for you to have a go at there for those of you that fancy challenging yourself on this exam question. And I look forward to seeing your answers for this. If you do have a go, indeed, because you know something like this could definitely be an exam question next year for you. So we need to be able to kind of tackle these things and at least give these things a good go to start off with. Little clue, if you wanted to, what I would think about is what is the volume of this water. That's what I would think about first of all. Okay. All right. So I look forward to seeing your pictures. What we'll do is we shall come back to your starter just to have a look at the answers. So I got, for the first one, 3.99 centimetres for the radius, and then I got radius is 4.68 metres for this one. I'm just going to double check these. So what I would do is you would work backwards from 400. So you would divide by 8 and divide by pi, which will give me 15